In this video, I'm going to talk about the Dojo 1 initiative, which is part of the ADAPT research project. The goal is to bring supercomputers with large language model capabilities to classrooms and to field those units for the benefit of the U.S. education system. So I'm going to cover a variety of things on this topic throughout this video, the vision and challenges to doing this, how we intend to make a computer like this, the impact and process of doing this, and how you can get involved in funding this research. There's a white paper that I wrote called Learn to Adapt that covers all the reasons why the U.S. education system should embrace AI and the benefits of that. But the key challenge here is that we have to bring AI at scale so that all classrooms, all learners can benefit. And we need to address and understand more about how to actually integrate those AI tools into the learning environment, how to make it fit the needs of the classroom, of the teachers, of those learners, how to make it personalized, and how to make it effective so that it actually produces the intended outcome. So we need to make these systems accessible. Right now, AI supercomputers are not something that every school can just put in their classroom. There's price point concerns, there's also design concerns, there's things that are just really uncharted waters. So we need to make the price point for this accessible for schools that don't have large budgets. We need to make the user experience very intuitive so that way it's very, very accessible for any level of student to interact with and learn a variety of topics. And we also need to measure the effectiveness of this. So if we just provide AI, but we don't measure the effectiveness and we don't actually know what it is producing, then we are missing the mark on that, essentially. So the project aims at addressing and understanding a lot more about all these challenges, and the research from this project will actually go out to everyone in the entire space as a finding that can be used for industry education, just to understand more about the problem and how to actually do this. So some of the key challenges here are the schools don't have these supercomputers. They don't have a current funding approach to do this. This is an unknown area. So one of the things we're going to do is just cut straight through that and use the research to fund the AI technologies and provide the systems straight through the Solana blockchain. So we're going to gather funding through Solana and provide that, design the systems, do iterative feedback to close that barrier. We're also going to develop methods, training for the educators and the students on how to actually embrace these tools. If you think back to long ago, not so long, but several decades ago when computers first, keyboards and screens started hitting, personalized computers started hitting the education space, there was the same sort of process had to take place. Now with AI computing, we're really just approaching things differently. So developing the actual methods on how to utilize these will also be part of the things that we develop, find, and provide to teachers and school systems directly. So right now, you can't just take ChatGPT, put it on an iPad, put it in a classroom, and have it address the needs of 30 students, right? So you have technical limitations there. Some of those are related to the power of the actual computing unit. Some of those are related to how it interacts with the human. So our goal is to develop hardware that is capable of that. And there's a couple ways that we'll go over later that we're intending to address that. And that framework is highly likely to be successful. It just is a matter of getting this off the ground, testing it, and iterating on this, and cutting through some of the conventional barriers that would exist if we were operating as a company. So how we actually design this hardware, one thing to keep in mind is that the price for compute and the chips that are coming out through companies like NVIDIA is completely groundbreaking, and it's bringing the ability to create systems at a price point that has never really been before seen. So if you look at NVIDIA's Digits project, they're talking about bringing these extremely advanced AI capable systems for like $3,000. So we think we can get high performance GPUs that can run all day, every day, and prompt and interact with 30 plus students in a classroom and really aid the teacher, teach subjects, tutor, assess students at a much reduced price point. So let's say you take 2 of these $3,000 NVIDIA GPUs, which there are some that are less than this digits chip, but I'm just saying that this is at a comparable benchmark. We would get things near this. We would assemble these resources together, and this could come from a variety of companies. So we'd acquire and assemble these computing resources, and then we would build everything around it that would make it work in the classroom. So there's a variety of middleware and other things that are part of this. So you need to build a tailored solution that's easy to use. And right now the vision is that you would have the hardware, an operating system, a large language model, and then you have this level of middleware that really interfaces with these sensors that then on the other end of those sensors is the human interaction. So seeing, hearing, and speaking are going to be core elements of the ease of use factor. So we want speech to text, computer vision, and text to speech to all be part of this. So a microphone, camera, and speakers. There's the Python middleware is essentially going to be a prompt engineering system that handles the two-way communication between the LLM, and those resources are just going to be the horsepower that keeps that thing running at volume and speed all day. So the goal is a sub $15,000 price point per unit. And like I spoke about with the NVIDIA Digits project, if you have 2 of those $3,000 units or 2 $1,500 units for, this is a widely available price point for GPUs they're quite hardy. You could get that, and then everything else you need to construct these computers that I've been showing representation of a small box that has the compute resources and the sensors that can do this. And we think we could do it for below $15,000 price point, which is very, very comparable to the types of resources that classrooms already spend money on in some school systems. So we'd like to get it to sub 15, maybe sub 10 in the future, depending on how things evolve, to make it so that this is something that could be replicated at its scale. So I go more into it in Learn to Adapt, but if we were spending this amount of money on every classroom in the United States, it would still be fractional in terms of the amount of money that we spend today, which is gigantic, and we don't achieve the positive effects that are exhibited by tailored learning, basically AI tutors. That those have already demonstrated in studies. Like if you watch, there's a 60 minutes presentation on Khan Academy's Khanmigo initiative where they're experiencing tons of firsthand positive benefits. So this would be the big focal point is that for that accessibility barrier is getting it to this price point, which you think is very reasonable. So the way that we actually implement this, so we get these into classrooms, and what we need to learn about is the collaborative learning environment benefits. How can the whole class engage? How can the teacher engage? How can all the humans in that room engage with that system? And what can that system really do? So there's a variety of things that are going to happen at that middleware level that are going to drive beneficial outcomes for this, where the engagement will go up and go down. As it starts, it's not, when we field the first system, it will not be a total home run. We're going to have to iterate on this, but the agreements that we're going to have with these school systems that we partner with, what we'll do, part of the agreement is that we will be updating and refining and gathering feedback on how the system is used to enhance the usability of it. So we are going to approach school systems gather insights about existing learning environments. It's key that we make these computers conform to public, private, co-op learning environments, these classrooms of all different types that actually have students in there with a teacher learning subjects. We want it to be something that complements current teaching practices and amplifies them. If you think back to, if you've ever attended public school, you would have a day with a substitute, and the substitute would come in and maybe put on a movie. Well, one of the benefits here is that with Dojo, you'd be able to approach continuing with your lessons, and Dojo would maybe be able to provide a lecture or be able to provide quizzes and assessments or initiate discussion or answer questions on the fly along the current chain of memory that those students are already following in whatever topics they're pursuing in that classroom. So we need to figure out what actually makes the computer achieve this, but we would partner with existing systems, and that's part of finding a scalable approach, because if we were to just find a computer that only fits one method or one environment that doesn't conform to multiples, we haven't really achieved a scaled approach. So this is one of the problems that needs to be conquered in order to make this work, and that will be a core focus of the research project. So partnering with the schools involves gathering feedback and refining the software and hardware iteratively as we're experiencing what it's doing in the real world. So we gather those insights, and part of those insights would go out as research that we would then publish, which would be to the benefit of the education industry, of the AI industry, of the computer industry as a whole. So these insights would be they would be available for anyone to use and benefit from, basically with the goal in mind of just making education better. We think that these tools could do it, and we just need to find out what ways actually achieve results and why the results back up these findings. So we would be gathering all that feedback, building iterative improvements based off of that, and developing in a low-code type of way, providing software updates that would enhance that middleware, assess the effectiveness of the current hardware, and we would just tweak along the way to find out what works and what doesn't. So the impact of this, I cover more in Learn to Adapt, but AI in education is already proving a variety of very valuable exhibits of enhanced learning outcomes. One of the core ideas here is that if you give a student individualized attention, if you provide them something that is tackling the forefront of their questions, of their knowledge gaps, it fosters a deeper understanding of subjects and potentially creates an environment where they can conquer those subjects in a much faster way, creating higher performance, potentially faster progression, better understanding, and additionally, it allows them to explore subjects that maybe one teacher can't provide, but with a Dojo unit with AI tools, they could explore much larger subsets of knowledge with a tool like this. So the goal is make education better, enhance those learning outcomes. We hold teachers just as important as students in this. So this is all about empowering the teachers. They have a very difficult job. They aren't paid at the level that I think it probably should be, my personal opinion. And we would be eventually providing a lot of personalized support to them. Speaking about the substitute scenario, there is a world where these systems get so good that they could handle very, very large portions of the instruction and the assessment of students at a level that is potentially superior to the conventional ways that we do testing, that we do quizzes, and the ways that we understand where students are at. So it would free up time for them to focus on guiding and mentoring students across their entire class, across their entire school, in a much more nuanced and thoughtful way. So we hold the impact for teachers to be just as high as the students. So for cost effectiveness, this just to hit on this again. So current solutions for education are, you'll have maybe a pack of laptops that are given to a classroom without AI. You'll have smart boards, you'll have projectors, you'll have things of that nature that are maybe there to enhance the learning environment and produce positive outcomes. But what we see the dojo as something that we can get to a cost effectiveness level where the dojo is going to produce for the money better learning outcomes versus the current solutions. So we obviously need to get these challenges addressed. We need to find out things about them, but basically learning about how to enhance learning is going to produce positive outcomes to make this a world that we can actually live in, where there's something like a dojo unit or actually a dojo unit comparable that is in every classroom, helping those teachers, helping those students learn better. So how can you get involved? This is where Solana comes in. So this project, all the research and all the findings will be produced and funded through the Solana blockchain. So this allows for a wide community to contribute to educational transformation in the United States. It allows us to, as a community, rapidly get after this directly. We're gonna, through this approach, be able to partner with schools, provide them something of value if they participate in this mutual goal. And I think that's going to erode a lot of barriers that would exist if we were a company issuing stock and trying to sell supercomputers at, let's say, a higher price point. We don't have a profit motive per se. And doing this, the only profit that we want to see is positive outcomes, or really just insights to be generated from this. The key to this is transparency. I think that's going to build the trust that's needed for community funding of an endeavor of this type. So through the blockchain, you'll be able to see all the use of funds. And you'll also, through updates on the X platform, be able to see how the project is going. That's going to be really important because there's going to be a variety of movement with the money to acquire these computers, build them, develop the middleware, develop the methods. All of it is going to be provided outward to build trust, build involvement in what we're doing. And we find that this is going to be the most, let's say, forward-leaning way to do this versus other methods of maybe, like, let's say, nonprofit approach, or like, let's say, through a company issuing stock and having that profit motive, right? The way that the money moves, the way it's utilized will all be publicly available. And we think that that is going to bolster success in this ultimately. The way to participate is really simple. You just buy and hold the ADAPT token or transfer existing cryptocurrency into ADAPT token through Solana blockchain. So you can swap for this token and hold it through Radium, and we're planning to expand to a variety of decentralized exchanges. You'll be able to see everything that's going on. The goal here is not to have any sort of investment, any sort of outcome other than funding that drives these outcomes. That money is a tool, and we plan to use this money as a tool to acquire these systems, put them in the hands of classrooms, put them in the hands of teachers and students all across the United States. And we want to be very candid about how that happens. So we think this is definitely the way to do it as cryptocurrency, as blockchain technology is evolving. There's so much potential here. I think this is really the future model for how to actually approach and do this. So if you think that this is something that you'd like to be a part of, you can definitely go hold ADAPT, and we definitely welcome that. You'll be able to follow and understand how much is being contributed, the progress of it, and all the updates through that as well. So that sums up the whole video. I really appreciate your time if you stuck with it this far to understand this. If you have any questions, please just reach out through X at adapteducation_, and we will be providing those updates as things progress and sharing ideas about how to approach this. So thanks so much for watching.